Hi guys, we are going to get started in chapter 2. So let me present my screen and we'll get right to it. Okay, so in chapter 2, we're going to start talking about conditional statements is what our first lesson is on, if-then statements. Okay, so we have some vocabulary here. It says a conditional a conditional statement is a logical statement that has two parts: the hypothesis, which we use P, and then a conclusion, which we use the letter Q to denote the conclusion. When a conditional statement is written in an if-then form, the if part contains a hypothesis and the then part contains a conclusion. So we look for the words if and then as like our hints to find the hypothesis and conclusion. So in words, it says, if P, then Q. Okay. In symbols, we write P and then this arrow Q, and we read that as P implies Q. All right. So let me give you some notes. Get my pen. All right. Move this over here out of the way. Okay. So in the notes, we're going to write a statement and then we're going to change it into what we call a conditional statement. All right. So my statement, find my pen. The statement is going to say, all birds have feathers. All right. If I want to turn that into what we call conditional statement, a conditional statement has to have the words if and then. So I'm going to take the first portion. I'm just going to underline it once. The first portion is going to be my P, my hypothesis, and the second portion is going to be my Q, my conclusion. Okay, so to turn this statement into a conditional statement, we would say if an animal is a bird, then it has feathers. All right. Obviously, I had to add some extra words to make the sentence make sense without changing the meaning. Okay, so I added an animal so that it just would make more sense. Okay, so that's an example of a conditional statement. Now we have what's called a negation. Move my cursor down. All right, the negation is the opposite of the original statement. To write the negation of a statement P, you write the symbol for negation, which is this little squiggly, before the letter. So not P is written as the little squiggly P. Okay, in words, we say not P. In symbols, you do a little squiggly and then P. Okay, so I'm going to give you some notes here as well. All right, so we'll start with a statement. So the statement might be something like, the ball is red. All right. The negation of that statement, so saying the opposite, would simply be, the ball is not red. All right, another example, so another statement, the cat is not black. So if that's the statement and we want to negate that statement, we'll say the opposite of that statement would say, the cat is black. Okay. All right, let's move on from negations. So next we have what are called related conditionals. Okay, it says consider the conditional statement below. All right, so it says, oh, there's no conditional statement below. Okay, don't read that with me. Let's just move on to the related conditionals. We have what's called the converse, and we're going to write a few in a second. I thought there's going to be an example here, but there's not. There's a converse and there's an inverse. So the converse is if Q, then P. So the conditional, again, right up here is if P, then Q. The converse, you flip the hypothesis and conclusion, right? So it would be if Q, then P. So in order to write the converse, all you have to do is interchange the hypothesis and conclusion. Now the inverse is if not P, then not Q. Remember we just did negations above and notice the symbols. Negate P implies negate Q. So you take the conditional and you negate both the hypothesis and conclusion. Okay, and we're going to do examples of both in just a moment. We have another one called the contrapositive. Okay, the contrapositive, to write the contrapositive of a conditional statement, you first write the converse and then negate both the hypothesis and conclusion. So it's if not Q, then not P. All right, so basically, if you're looking at the conditional, you have to flip and negate the conditional, is how you write the contrapositive. All right, so next it says a conditional statement and its contrapositive are both true or both false. Also, in that same way, the converse and the inverse of a conditional statement are both true or both false. These are what we call equivalent statements. And this is pretty important because it'll help you when you're determining whether or not a statement is true or false. I'm going to just kind of start right here. All right, so again, the conditional and the contrapositive kind of pair up. If the conditional is true, then the contrapositive will be true. If the conditional is false, the contrapositive will be false. And then the converse and the inverse are equivalent statements. If one is true, the other is true. If one is false, the other is false. The reason, again, that this is important to know is sometimes when you read these statements, it might actually be a little tricky to determine if they're true or false. But if you remember that if one's true, the other's true, or if one's false, the other's false, it can really help you conclude truth or if a statement is true or false, okay? The last type of statement that we're going to discuss is called a biconditional. Just scroll down a little bit. So when a conditional statement and its converse are both true, you can write them as a single biconditional statement. A biconditional statement is a statement that contains the phrase if and only if. Okay, so in words, P, if and only if Q. In symbols, P, and then we have the double-headed arrow, Q. And we also use the abbreviation instead of writing if and only if for every single statement. Why is my pen not showing up? Sorry, guys. Pen. There we go. What you can write is just IFF. That's our abbreviation for if and only if. So in our statements, you can just write IFF. Okay. All right. It says next, any definition can be written as a biconditional statement. So we're going to do a little practice here. Let me just scroll up to give myself some more room. Oh. Okay. And let me get rid of that. All right, so I'm going to give you a statement and we're going to practice writing the conditional, the converse, the inverse, the contrapositive, and the biconditional. So you can see how this all fits together. Okay, so the statement is, the given statement is going to say two supplementary angles, supplementary angles have a sum of 180 degrees. Have a sum of 180 degrees. All right, so then we're going to write the conditional. Actually, actually, let me get that off the screen to give myself more room. I'm going to write the conditional. We're going to then write the converse. Then we're going to write the inverse. And then we're going to write the contrapositive. And then we're going to write the biconditional. All right, so first off, notice that the statement given is a definition, right? It is what the definition of supplementary angles is. Supplementary angles are two angles that have a sum of 180. All right, so if you want to write that as a conditional, you're just going to take the first part of the statement and make that your hypothesis. So the hypothesis is going to talk about two supplementary angles. And then you're going to take the second part of the statement and make that the conclusion, have a sum of 180, okay? So as a conditional statement, you would say, if two angles are supplementary, if two angles are supplementary, then they have a sum of 180. Okay, there is your conditional statement. If P, then Q. So keep that in mind as well. Your conditional is if P, then Q. Remember, P just represents the hypothesis and Q represents the conclusion. So your hypothesis for this statement, two angles are supplementary, and your conclusion for this statement, they have a sum of 180 degrees. Notice how I didn't underline the words if and then. If and then are just the hints, the key words, the clues that we look for, but they are not the actual hypothesis or conclusion. The converse, the if and the then stay where they are, but you flip-flop the hypothesis and conclusion. So the converse would say, if two angles have a sum of 180, then they are supplementary. And I'm going to abbreviate and just write SUPP from now on, okay? All right, so notice that I flipped my hypothesis and conclusion, but I didn't flip word for word because I wanted the sentence to actually make sense. So as long as the idea is flipped, right? The hypothesis was talking about supplementary, the conclusion was talking about sum of 180. As long as those topics are flipped, it doesn't have to be exact word for word. You can kind of change the words a bit or keep some words to make the statement make sense. But notice now it's if Q, right? The Q has to do with the sum of 180, then P. So I flipped the hypothesis and the conclusion. Okay. All right. Next is your inverse. So your inverse is if not P, then not Q. So you're going to negate the conditional. So you go to the conditional, but negate it. So you're going to say if two angles are not supplementary, then they do not have a sum of 180. Okay? And again, we say if not P, then not Q. All right. And then we have the contrapositive, which the contrapositive is if you go to the conditional, you have to flip and negate, Or you could just come to the converse and think, okay, I just have to negate the converse. It's kind of up to you. I like to always go to the conditional and think about what I need to do to the conditional. So I need to flip and negate, okay? So you're going to say if two angles do not have a sum of 180, then they are not supplementary. And for that one, it's if not Q, what color is Q? Yellow. If not Q, then not P. Right, the last one we have to write is the biconditional. So the biconditional, you can write if both the conditional and the converse are both true. So let's talk about whether or not they're true. If two angles are supplementary, think about that for a second. If two angles are supplementary, then they have a sum of 180. Okay, well, that's true because that's what supplementary angles are, right? Supplementary angles are two angles that add up to 180. Okay, so that's true. The converse says if two angles have a sum of 180, okay, so if two angles have a sum of 180, then they are supplementary. Well, that's true as well because that, again, is the definition of supplementary angles. So because both of those are true, you can then write a biconditional. To write the biconditional, just go up to the conditional, drop the if, drop the then, and put IFF between the between the P and the Q. Okay, so the way you would write that is two angles are supplementary if and only if they have a sum of 180. Okay, this if and only if, this is what makes it a biconditional, this wording right here. Okay, and again, you can use IFF instead of writing it out, which is fine as well. All right, but that is how you write your biconditional. And the biconditional is P if and only if Q. Okay, that's the notation there. All right, so last thing we're going to do is talk about whether or not each of these statements is true or false, just so we can talk about those equivalent statements again. So we already said if two angles are supplementary, then they have a sum of 180. We said that that was true. Okay. Then we also already read the converse and decided that was true as well. I'm just going to put a T there. Okay. The inverse. Okay. The inverse says if two angles are not supplementary, okay, so if they're not supplementary, then they do not have a sum of 180. Well, that makes sense because if two angles are not supplementary, then they wouldn't add up to 180. Because if they did add up to 180, they would be supplementary. And then finally, if two angles do not have a sum of 180, okay, so if two angles don't add up to 180, then they're not supplementary. Well, that's true as well. Okay, so all four are true. Okay, and remember your conditional and your contrapositive are equivalent statements. So if one is true, the other has to be true. And the converse and the inverse pair up. And if one's true, the other has to be true. If one's false, the other has to be false. Okay? All right, let's keep on moving along. All right, actually, I think, let me just look at the example problems I want to look at. That actually is it. That's all I wanted to do. Cool. Let me go back here. Stop sharing. All right, guys. So that is it for lesson 2.1. I'll see you back here for the next lesson. Bye.